Okay. Let's do what we need to.
You're the same one, yeah?
Yeah, and then we're going to do one more section. Tomorrow we'll finish off dynamics. Friday we'll start with statics.
There's too many equations. Yeah,
So many options, yeah.
Looking at it, okay. When I use this, if you, everybody think now you're using the whole equation. Because most of some of them, like these ones, that's got S. S is equal to this and that. And you're like, okay, I can use this one. This one, no, it's not that one.
I know.
Yo.
And then if it equals in, then it's also equal to in A.
Exactly.
But it's the same thing, it's just the gravity. So,
Hey, but you see of F minus FMG thing is equal to MA.
that's one of the questions.
Hey.
That's one of them because, which one was it? I think it's question 5.
Yeah, question 5.
Yeah, it took me a while to figure out that.
Yo.
I hope I got that.
Okay.
Yeah.
Okay.
S. Yo.
Let's go. So, similarity
So many S's.
3.1.
3.1. Looking at question 1.
1.
So, I tell you that a car is moving on a horizontal road at a velocity of 90 kilometers per hour. So, you have a vehicle on a horizontal road. It's moving at
90.
initial velocity is equal to 90 kilometers per hour. The brakes are applied and it comes to rest after a distance of 60 meters. So if it comes to rest, its final velocity is 0, and after a distance of 60. So your S is equal to 60 meters. Mass of the car is 900 kgs. Calculates the deceleration. So, how would you calculate the deceleration? Using the information given to you, you go look at your formulas and you'll see. Right, you're going to look at which formula you can use for acceleration. So, we know final velocity.
Yep.
We know initial.
Yep.
Time.
No.
We know displacement. Initial.
Yeah.
Time.
No.
Final.
Yes.
Initial.
Yes.
Displacement.
Yes.
And we're solving for acceleration. So, we'll say, okay, I'm making that the subject of the formula, right?
Yeah.
So, I'm going to say A is equal to V squared minus U squared all over 2S, right? So, this will be equal to 0 squared minus, what we need to do to this? Convert it to meters per second. So, if you convert it, what it comes to?
25 meters.
So remember this here, you just multiply by 1000 divided by 3600. Okay? So this here would be 25 squared all over 2 times 60, which is will be negative, right? 5.208 meters per second squared. Okay, it's deceleration. So you'll say, therefore, deceleration. How is deceleration? Deceleration is equal to 5.208 meters per second squared. Okay, so then they ask you to work out the braking force. Okay? Now remember, Newton's second law is F is equal to ma, right?
Yeah.
The braking force would be what's being applied to stop this car.
Yeah.
So the force that's being applied to stop it would be equal to your mass times the deceleration. Because whatever it's decelerating by, that's the force that's being applied to stop the car.
Yeah.
So this would be equal to 900 times 5.208, which is
4687.2
Newton. Okay? That's fine. Okay, then the last one, they ask you time taken to bring the car to a rest. So, if it's time taken, we're going to look at these formulas again. So, based on the information we have, let's see what we can use. Yeah? We know final velocity,
Yes.
we know initial,
Yes.
we know acceleration, yes, so we can use that formula as well to work out time taken. Okay, or you could have used the other one with the displacement. So here you'd say make time subject to the formula, it will be equal to v minus u all over a. So this will be equal to 0 minus 25 all over 5.208, which is
130.2.
No, minus 5 there.
yeah, but because it sees deceleration, because it's time, you would obviously take it as an absolute value because you can't get a negative time. So this here would be
Oh, the reason why I put minus,
4.87.
yeah,
Seconds.
but the reason I put minus
So that it
5,
cancels.
it cancels.
It cancels out, right? Because remember, this number is gonna come out
Yeah.
to a negative number. But can you get a negative 10? No. So you'll take the absolute value of it, which is
Yeah.
that. Okay? If you use this formula here to work it out, you would have got the number in terms of positive value. Okay? Okay.
So this is the kind of questions.
It's never this easy.
Good?
It's never this easy.
I know. Yeah, but interpretation is
That's the thing. And especially in this section, because the way they ask you, like you see, total force will be equal to a certain value.
yeah.
But then when they say like resultant unbalanced, then that's a separate thing you need to do.
Yeah, so like yeah, we need to go to the understand.
I'll show you what that means.
I'm assuming if we use one of the others, it should have still been exactly the same.
Like I see, in my working out, I use the S is equal to U plus B over 2 times T. And then,
That's when I'm looking at that case. This and you actually use 25 plus 0, 25 divided by 2, 12.5.
and then be 60 over.
Multiply it. Should it? No, it would have been 5. 60 divided by 12.5.
Yeah,
Put it in. Oh, it's right then. Put it today.
yeah, okay. Yeah, because it wouldn't have been 5.
Oh, yeah.
It wouldn't have been 5.
Yeah, 12.5 is
If 12.5 would have been 4 times, that would have given you 50.
yeah.
And then a little bit more would have given you
Little extra, yeah.
20.
So 62.5.
Would have been 5.
Yeah.
Exactly. You okay, guys? And move on. Okay, so question 2. They tell you that a truck is moving in a straight line. So the truck is moving on a straight line on a horizontal road at 120 kilometers per hour. So its initial velocity is equal to 120 kilometers per hour, and it's brought to rest. So its final velocity is 0 during a time of 15 seconds by a braking force of
20,000.
So this will be 20,000 newtons.
Yeah.
Right? 20 kilonewtons is 20,000 newtons. So they're asking you to
Calculate the mass of
the mass of the chuck. So first thing, let's convert this to kilometers per hour. How would you convert that?
33.33.
So this will become 33.333 meters per second. Now, question asks you to work out mass. What formula do we use that has mass in it? F is equal to ma, right? We want to work out m. The force we can use to work this out is the braking force that they gave us. Okay? What are we missing? A. So what we need to do? Solve for A. Okay? So to solve for A, we need to see what information we have and what we can use from these formulas to solve for A. Okay? Do we know final velocity? Initial? And do we know the time? So we can use that formula to solve for acceleration. So if you are to make A the subject of the formula, it will be V minus U all over T. So this would be 0 minus 33.333 all over 15, which will be minus 2.222 seconds, meters per second squared. But remember, this is deceleration, which will be equal to 2.222 meters per second squared. So now F is equal to mass times acceleration. Your force is 20,000 equal to mass times your deceleration is 2,222. Therefore, your mass will be equal to 9,907 kg. 900 kg.
Yeah.
Fine. That was okay, right?
I use a different one.
What?
See,
What you use?
the S plus U plus V over 2.
S is equal to U plus V over 2 times T.
Yeah.
But what you solve?
The mass.
How?
How you?
Cos the U, we know the U is 5.
We know the U,
We know the U, we know the V.
we know the T. And then you solve for S.
Divided by 2.
Right? So we solve for S then. And then after you solve for S, what you do?
What formula?
Oh, I came to the wrong answer because when I substitute the S in the next one, gives me 8.
So you solve for S and then you use that F is equal to MA after that. Let me check it.
Oh, so you mean for the acceleration you use a different formula?
Yes, you use the S plus V.
Okay, so you solve for S, right?
How?
Then you use the
Okay,
different
okay.
formula for A. That's fine. So you said V squared minus U squared all over 2. Yeah. Yeah. But what you did would have been right. Because okay, you went the longer way, but you still be there because you solve for S, you use S to solve for A, and then you substituted A. Where you went off was you use kilometers per hour instead of meters per second, and you would have known to use meters per second because you would have your senior time is in seconds. Okay, let's do number 5. You enjoyed number 5.
Hey,
And
that was
makes us
yeah.
make us think.
Let's see number 5, right?
So problem number 5 was the formula, but you've got to obviously adjust
Yeah,
to
you need to
compensate
know
for-
what you're working with and
Yeah.
what to use to get there.
Yeah.
Okay, so for number 5, they tell you a car with a mass of 900 kgs accelerates uniformly from rest up an incline. So this car is on an incline, it accelerates uniformly up the incline. So it started from rest, which means its mass is 900 kgs. Uniformly up means that it went up from, it went up from rest, which means 0. It reaches a speed of 80 kilometers per hour, so its final velocity is 80 kilometers per hour. Well, the incline is
1 is to 4.
1 is to 40.
Yeah, 40.
Reaches a speed of 80 kilometers after 90 seconds. Calculate the acceleration of the car. Okay? So remember, this car is now on a incline. It's moving up the incline. Okay? Based on the information they gave you, let's make everything in terms of what we need to have it in to work with it. So as 80 kilometers will have been
22.22.
meters per second. Your slope, I told you the angle would be equal to shift 10, 1 over 40. Right? So your angle would have been
1.432.
degrees. So this angle here is 1.432 degrees. Okay? Let's look at firstly the acceleration. Let's work it out. Okay? The information we have. We know final velocity, we know initial, we know time. So we can use this formula now to work out the acceleration. So A is equal to V minus U all over T. So this here is equal to 22.222 minus 0 all over 90, which is
0.247.
meters per second squared. What's the time? What's the time? Come here, pretty much. Alright, that's our acceleration. Let's move on. Right. The total force applied, okay, which is your applied force. So you know when you're balancing all your forces, that F that's moving up, that's your total force. Okay?
Yeah.
What's acting against this would be
friction.
the friction. So remember, gravity is acting down.
Yeah.
This gravity will be broken up into its component.
Yeah.
How would you work on this component?
Sine.
mg
Sine of the angle.
sine of the angle.
Yeah.
So that's what's acting against it. They never tell you that there's any other friction acting on it. It's just this is moving away, that's moving it up. Okay? So how you would have worked this out, you would have said the sum of the forces acting on the object is equal to mass times acceleration.
Yeah.
Sum of your forces, positive F minus the gravitational force that's acting on it, which is mg sine of the angle, equal to mass times acceleration. Are we all okay with it?
Yeah.
Right. This is what we try to work out. Minus m is 900, g is 9.81, sine of 1.432 equal to 900 times this acceleration, which is
0.247.
0.247. Okay? So, okay, F is E minus, what's this now value? 900,
8829.
8829.
Yeah.
Yeah.
That's all.
Yeah.
And then this here is?
That final answer
No, this is the final.
20.5. That 88 is validated the force possible.
No, hold on. Then what about the?
I'm just asking, I'm asking what's
The
this?
whole
No.
thing- The whole thing is 220.416.
So F,
Is it 416?
Yeah, 8820. 2029.
Yeah, 614.
Tell us.
Let's see.
Which one number you have used? This one?
He wants the whole thing.
No, I just want this here. Just,
Yeah.
okay, 900, that's this number, right?
Yes.
Right.
Yeah, it's
Equal to,
220.
what's 900 times 0.247?
No, the x minus
Just
the
the
And
first
the
one
other
is
one
the
is
first,
the
the
first part is
first
220
fictional force, and then
This?
no.
No, the 900.
29 is wrong.
It's
So
right.
it's
No,
wrong.
no. What about this side?
Oh, you said
Yeah,
this
okay,
is this.
yeah, 900 times
Nine-
two,
Oh.
The sign.
Okay,
Then you
no.
put a sign.
Give me 900 times 9.81 times sine 1.43.
220,641.
220,641
Yeah.
equal to 900 times 0.247.
It's 222,3.
That's all. That's all.
Yeah.
Yeah.
Okay.
Yeah.
So F would be equal to, you take this across,
Yeah.
so it will be 222.3 plus 220,641. F is equal to 442.941
Yeah.
newtons. So that's the total force. That's the force being applied.
See, my one had, I did exactly like how you're doing it, but the only difference was I had the frictional force. So now that's where I got confused now. How do I
Why
get
you
the
add
frictional
frictional
force?
force? Unless they tell you that there is frictional force acting on it, you don't need to add it.
Okay. So because that's why my answer had F minus frictional force is equal to
Minus the gravitational equal to
What you
ma.
used for frictional force?
No, my answer was F minus frictional force is equal to that 442.941. So that's where I stopped.
Oh, cause yeah. But there was no frictional force acting on it. Okay? So that's that. We're okay with that.
Yeah. What I did was I broke it up into two calculations. So I did the if G is equal to MA sine theta.
Yeah.
I
The
did that
gravitational
first.
force.
So the 220 I did first.
Yeah.
Right. I did it on its own. And then I did this other one where it's F minus FG equal to MA, and then I moved it across.
That's
it. Okay.
If you want to parts it, that's
But I
fine.
didn't-
I
parts,
just put the whole thing together, right?
Okay, alright.
Okay. Now the next question. The resultant or the unbalanced force. So you may be wondering, what the hell does this mean?
Yeah.
Right? If you go to if you go to page 47, okay? Go to page 47, under the formulas at the top, right? It tells you when we take the forces involved into account, the formula we use is F is equal to MA, where F is the resultant force or effective force and is also called the unbalanced force.
Yeah.
Okay, so what they basically asked you was just take F equal to MA. So that's all they want. So your unbalanced force would be F equal to MA. Total force is where you'll do the balance of all the forces acting on the object equal to MA. You know, the sum of the forces equal to MA. And you'll solve for the force applied. That's your total force. Okay?
So that's what you're saying is the total force, the 442, right, to overcome the gravity section, which is the 220.
What force is needed to?
Yeah. So so that means that minuses, that takes away the gravity, right?
Yeah.
Out of the 442. So what's left is what is causing the acceleration up.
Which would be the mass.
Yeah, just 220.
Right.
222.3.
So this here would be F equal to MA. This is equal to 9,000 times 0.247, which is
222.3.
9,000.
900.
sorry.
No.
Sorry.
2.3.
Triple 2.3. Oh yeah, it's that right. Right? Newtons.
Yes.
That's your answer. Who's completely lost?
And if you see it,
Please let me break it. It's sum of F by B
Yeah.
equals to NAF minus MG sin theta.
Yeah.
Confused there.
With that part. So remember with Newton's second law, it's the sum of the forces that act on the object equal to mass times acceleration. This is your object, right? The object is on an incline. There's a force applied that's obviously moving it up the incline. Regardless of whatever circumstances on the incline, gravity will always be pulling this down, right? Whether there's friction or no friction, gravity is always going to pull this down. So gravity will obviously act in your negative direction. The force applied will be your positive direction. Yes? So that's how I ended up with. So there's two forces acting on this. This gravitation. So this is the gravity force down. But remember, we'll break it up into the component that's actually pulling this car down. Understand that? So the force applied would be a positive force minus the force that's pulling it down, which is the gravitational force, which is equal to mass times acceleration. And the total force is your applied force, which is F. And then that's what we used to work with. Right? Did you get a question?
I was going to say, as I've explained that whole thing, if you just did the calculation to say that final force minus your gravity force, still gives you that total.
Yeah, because remember, this here, this minus this is equal to MA.
Yeah.
This here is MA. So it's still equal to that force. So that's the force that's actually being generated from the vehicle. So when you put your accelerator down, the force that the engine actually creates, it's M times A. The mass of the vehicle times how much you're accelerating by. Okay? And then the force balances obviously because of what's pulling you down, if you got like something helping you move, that sort of thing.
So you only put this frictional force only if they give it to
If
you.
it's given to you. Or you'll see like in the question, if they ask you, calculate the frictional force, they're basically telling you that there is a frictional force, work it out. Okay. Are we all okay?
Because I only took it like because for anything that's going to be moving, especially in a slope, there's always going to be frictional force.
In a slope, there'll always be gravitational force.
Okay.
Okay, because it's acting on an incline, there'll always be gravitational force.
Okay. Anyway, I did my homework on Sunday. and I was working with Prophet. Is it right?
Respond with that.
Eh?
Yeah, respond.
Yeah, you did.
Yeah.
And the response was quick.
Oh, you always checking your homework for that. You're checking your homework for that.
What's your university? Towards the evening.
Yeah?
Towards the evening.
Afternoon? Yeah, yeah, Sunday afternoon.
Okay. You know, I'm going to take it down and then move on to the next part. When your test 2, your engineering science test 2 is on 22nd.
22nd, yeah.
How long 22nd?
That's about 3 weeks away.
3 weeks. Now it's what, 20
Yeah, that's 3 weeks. It's 28.
weeks, so that's about 3 weeks.
So if I finish dynamics tomorrow, Friday hydrostatics, next week, Wednesday, Thursday, Friday hydrostatics. The following week is just, not next week, the following week.
3 weeks.
Oh, shit.
Why you make it?
No, you got this week. Okay, so we got 4 lectures. We got 1, 2, 3,
And
4
then you
lectures.
write
4 lectures in that.
4 lectures.
That's here. The 7th, the 14th, and the 21st.
You got 4 weeks.
4 weeks.
Yeah.
After
You said we're out to the 22nd, no?
So your Wednesday, Thursday, Fridays are Wednesday, Thursday, Fridays.
We got
It's 12.
this week. I'm putting this week tomorrow. That's 1, 2, 3, 4.
So we got 4 Wednesday, Thursdays, Fridays. So we got 12 days.
Yeah.
So finish this tomorrow. 11 days. 4 days for statics. Yeah.
Just maybe.
We can do it. I have full faith in you. So we must keep
easy.
day for revision too. But I guess the Wednesdays I can't go a bit longer because it's only me.
Yeah.
Oh, maths.
Oh yeah, you got maths.
When?
From when? Yeah. But maths, he said he's on. He's not. But yeah, you don't really know definitely.
No, he said he's buying and that Jaffet's gonna take over.
That's why I'm saying. So, if I'm seeing you on for Wednesday, I can see how the maths goes.
Yeah.
Because from here, the first 2 sections you did was determinants and complex numbers. That's okay. After that, you're going to do trig. Trig, yeah, one day it does get a bit difficult. Lot of rules, right? Trig, graphs is okay because graphs is that's set things you need to remember. Determinants and integrals, that's going to take time and it's going to be difficult. I will not lie, but it's not impossible. And remember, that's determinants and integrals count for 50% of your exam. So obviously, I need you to know that 100%, right? So we'll get there. Okay, we'll get this, guys. Try. Even if I call you here on a Sunday too. So yeah, this is one moment. We push for this month. You're done after. You can go back to whatever you're doing until we do N5. Then I'll come back. Right? We okay?
Yeah.
Guys, check it out. I'll leave this formulas here. Try the N5 is easier, guys. It only gets easier after this.
Are you serious or?
No, I'm being serious because, like I said, M4 is difficult because you're coming back to everything, you're getting back in the groove, still learning each thing, everything is new to you, that sort of thing. N5, you see like how in this textbook, every section we start, they tell you, like see on this one here, they told you, Newton's laws is not something new, or it's not the first time you have heard of Newton's laws, you worked with the famous law in N3. When we did angular motion and stuff, they said you would have learnt about this in N3. First section, you would have learnt about this in N3. Same in N5, they tell you you would have learnt about this in N4, which you are doing now. So when you go there, you'll have that foundation, and then we just build a little bit more. Right? So you'll be fine. Go ahead. Just N4, we go through. Right, let's look at page 51. So, we're looking at work done and power. Okay, so don't confuse it with angular motion. What you'll see is that for work and for power, there's a formula to it, right? But for each section, the formula will be tweaked a bit because, like you see in angular motion, distance was angular displacement. Displacement means what? The shortest distance, right? So in that section there, work was equal to force times angular displacement, or it was equal to force times r. R was also a distance, right? Yeah. So you'll see in this formulas here, right? Okay, let's read, right? For work to be done, energy must be available. Energy is described as the ability to do work. When a force is displaced, meaning that it's moved, it is an indication that energy has been transferred and work has been done. Work done is the product of the force and the displacement of its point of application in the direction of the force. Therefore, work is equal to force times distance. F times S. Okay? Work done and energy are scalar quantities. This unit is N newtons per meters or joules, meaning that it doesn't have direction, it's just a scale. Okay? The rate at which work is done is called power. That will be the definition of power. The rate at which work is done is called power. Okay? Another thing, remember, if they tell you the rate of something, whatever that something is will always be over 10. The rate of is basically 1 over 10. Okay? So even your definitions, you know when we said definition for angular velocity, it's the rate of angular displacement. It was this over 10. The rate of angular displacement. So the rate of is basically 1 over 10. So if I tell you the rate of velocity, velocity over 10. The rate of acceleration, acceleration over 10. Okay? Then they say the change of rates, it's basically t2 minus t1. Right? That's everything. Okay? Because I saw a lot of you wrote change off in the test. It makes a difference, okay? So in your definitions. Okay, and is the work done per unit time? Okay, so power is equal to, remember, work done over time. The work done formula is force times distance. So that's how they got power is equal to force times distance over time. Force times distance is work. Measured in joules per second, 1 joule per second is equal to 1 watt. Okay? The power is the watts that causes the production of energy at a rate of 1 joule per second. So we got our formulas, right? We know that work done is equal to force times distance. And the other one is power is equal to work done over time. So power is equal to work done over time, which is the same as saying force times distance over time. And then you see we got F times V. Right? That means force times velocity. Okay? How they got force times velocity? If you look at this part of the formula, distance over time is what? S is what? Distance.
Yeah.
Distance over time is velocity, meters per second, which is velocity. That's how they got F times velocity. Okay? But I don't think you'll use that one much. You'll use the work done over time. Okay, so is everybody clear on that?
Yes.
Everybody understands? Okay. So let's do an example, right? They tell you that example, an object with a mass of 15 kgs is at rest on a horizontal plane.
Yeah, it's a.
Yeah. Okay. So the mass is equal to 15 kgs. The object is at rest, so its initial velocity is 0. The resistance against motion is equal to 8. Okay, 8 newtons. So the resistance against motion, which is basically a frictional force, is 8 newtons. The object is displaced through 50 meters, so S is equal to 50 meters during 25 seconds by a horizontal force of 20 newtons. So the force being applied to this object is 20 newtons. We are clear on, we understand what the question basically gave us, eh? Guys, everyone? Okay.
Yeah.
Right, so calculate the work done against resistance. So the first question, they ask you to calculate the work done against resistance. The formula for work is equal to force times distance. So work is equal to force times distance. The work done against resistance, remember that will be the sign for resistance. So which force would you use? Where you got 5? Why would you use applied if they're asking for resistance? See, in the question they tell you the resistance against motion. So you would use that force, frictional force. Okay? So this would be equal to 8 times it was displaced by 50 meters, which is equal to 400 newtons. Simple? Everybody understands that? So you see where you're okay?
Yeah, I'm following.
Got that, right?
Work done against resistance, so that's why we're using frictional force. Okay.
Right? Because they ask you for the work done against it.
To overcome the friction basically.
Thank you. Thanks. Okay, then they tell you the work transformed into kinetic energy. Do we all know what's kinetic energy? Potential and kinetic energy?
Yes.
At some point you learn potential is stored energy, kinetic is movement. Right? Now remember something. In this formula, F is equal to MA. Right? MA is basically the force or the energy that's being applied by the object itself. Remember we said that, like a car, the engine will give you the MA. The force that it has stored energy in the engine. When you press the accelerator, it accelerates at a certain amount and it moves that mass. So that's the point that's creating, moving potential energy into kinetic energy. Do you understand that?
Okay.
Everybody understands that, what I just said? Who's lost on what I just said?
Repeat it.
Okay, pay attention then. Kinetic and potential energy, right? Remember, potential energy is stored energy, kinetic is movement. For this object, remember in the last question, we said, for example, if it's a car, if it's a truck, right? That MA, mass times acceleration, where is that coming from? That's coming from the car. Nobody's pushing the car, nobody's pulling the car. That energy MA is coming from the car, right? When you press your accelerator, you're applying some form of acceleration. And what is that acceleration moving? It's moving that mass, right? So when that happens, you are creating kinetic energy.
So as soon as you press the accelerator, so you're moving from potential to kinetic.
Yeah, because remember that engine has a stored amount of energy, and then once you apply, you start moving that energy, then it converts into kinetic. And it moves because of the acceleration that's moving the mass. Do you understand that? Okay. So when they asked us to work out this question here, the work that's transformed into kinetic energy. So for B, work is equal to force times displacement. So which force are they looking for? F is equal to MA. That's what they're looking for.
There are 20 newtons.
No. Don't mix up MA and the force applied.
Okay.
That F you would use when you're doing the sum of your forces, the total force that's being applied. I'm talking about the force that's created by the vehicle itself, the MA. Okay? So, we don't know the acceleration. Right? We can do one of two things. We can either solve for acceleration and then solve for the force, like you know the mass times acceleration, or remember the forces that act on this object is what? F and your friction.
Yes.
So wouldn't F, your friction, the force applied minus the frictional force be equal to MA?
Yeah.
Oh, yes.
Yes? We all see that, right?
Yeah.
Okay, so here you could have said F minus the resistance force times your displacement. That's the same as saying, it's the same thing as saying MA times S. Because remember the sum of your forces is equal to mass times acceleration.
Yeah.
The sum of the forces acting on this is F minus the resistance force. It's equal to mass times acceleration. So we can use this here, and we know this value and we know this value. Okay, so here you could say 20 minus 8 times 50, which is 600 newtons. Does everybody understand what I just, not newtons, man, joules?
Yeah. You're still stuck in the past.
Yeah. Still working for us.
Bring it in forward.
Do you understand what I said? Do you understand what I did? Okay, so when you see kinetic energy, when they ask you for kinetic energy, they're referring to mass times acceleration. Because we didn't have the acceleration, but we knew the sum of the forces that's being applied, we could use that. Good.
Can you take that down?
Yeah, you take it. Engineering science got too much words.
Hey.
That's a lot.
No, I think yeah, maybe the sequence they ask. Maybe if you ask C first,
Yeah, and then you go there.
and you work backwards.
But then they want to check it.
I know to make you work.
So yeah.
Here's a question. If you for C, right, would you be incorrect? Okay, but you wouldn't be using a formula if you just basically add it up.
Still the same.
I know it'd be the same thing, but basically, yeah, you wouldn't be using a formula, but you'd be saying to overcome the resistance plus the actual, and you combine them together.
That would be your total force.
Yeah.
Guys, you got it? Number one. Okay. Now your total work done will be equal to, okay, work is equal to force times displacement. Your total work done is basically the applied force, which was given to you, which was 20. So this would be equal to 20 times 50. Okay, this is equal to 1,000 joules. Is that fine? Okay, then they said the total power. Okay, oh, what? Did you get anything else? No. Okay. Okay, so they tell you the power. Okay, total power would be power is equal to work done over time. We worked out 3 different values for work, or 3 different work done. Right? We worked out the resistance work, we worked out the kinetic energy work, we worked out the total work done. Which work do you think you would use? The total, because they asked you for the total power done. Okay? So this would be equal to 1,000 all over 25, because 25 seconds. Okay? And I think it's 40. 40. That's 40 watts. Is everybody okay with it? See, the next question is what they'll ask you. Because you know you love angles.
So, yeah, so basically it would be 40 joules per second.
Yeah. 1 joule per second is equal to 1 watt. I'm just thinking, how you're going to hate me after that. How you're going to hate me after that.
What?
One way or the other, I'm going to chill the thing into your bed.
That's what we want.
I love that.
No, that's, yeah,
So
it
you
needs-
must know.
It needs to be like second nature. So you mustn't even realize you must just be, as soon as you see it,
Going.
Give us our WhatsApp as long as we see the results.
yeah. I mean, and we thank you for that, so. Yeah. No, it's true. How it's
You know me bed. Okay, I'll continue after this. Okay, can we move on to the next example?
Yeah.
Checking out, you said that? Right, 3.7. So, tell you that a car with a mass of 850 kgs accelerates uniformly from rest. Okay, so it's moving an incline, right? So your car is here. Okay, so the mass of the car is equal to 850 kgs. The car accelerates uniformly from rest. Its initial velocity is 0. Final velocity is 100 kilometers per hour. During 8 seconds, up an incline of 1:20. So the car is moving that direction. So its slope is equal to 1:20. The frictional resistance is, see now they mentioned frictional resistance, right? The frictional resistance
300 newtons.
300 newtons. Before we carry on, let's go. Right? Remember, on an incline, what will always be there on the incline? Gravity, right? Gravity will act like this. So when we break gravity up into the component that actually affects the car, it's going to be mg sine of your angle. We all know that, right? We all okay with that. Before we carry on, let's sort our values out. So this would be F. Okay? So this 100 kilometers per hour, we convert it to meters per second. So that would be 100 times 1000 all over 3600. Or you can just divide by 27.778 meters per second. Your slope, your angle is equal to shift tan 1 over 20, which is
2.862.
okay. So this here is 2.862 degrees. Okay, guys, take it on after I said pay attention because I want everybody to get this so that we don't have an issue, right? Okay, what's the question? Okay, now we got everything else we needed, right? Oh no, let's work at mg, right? So this force acting here is mg. This is 850 times 9.81, which is
It's 833.8.5.
833.8.5. Okay? Now we have everything that we could possibly do with whatever we have. Let's see what the question asks, right? The work done against the frictional force when the velocity has reached 100 kilometers per hour. So they want the work done against frictional force. So for A, work is equal to F times S. They want the work done against frictional force.
So it's going to be F. W is equal to F. Yeah.
Right? Okay. We know this force. Do we know how much this was displaced by?
That's a distance that they give us.
No.
No, not distance.
Never gave us the distance. So we'll have to use one of our formulas in the top to work out distance. So let's do that. That's no distance there. Here, do we know initial velocity?
Yep.
Do we know time?
Yep.
Acceleration?
No.
Time?
Yes.
Yeah.
Final velocity?
Yep.
Initial?
Yeah.
We can want displacement, or do we know acceleration?
No.
No. Displacement, initial, final,
Yeah.
time. Can use this one. Right? So, before we come back here, let's say S is equal to U plus V all over 2 times T. This is equal to,
So what's wrong with using the last one? When do we use the last one? S is equal to VT.
S is equal to, that's initial velocity times time. That day you would only use on a horizontal plane. Remember when we did angular motion? Because remember, this is basically this.
Okay.
Right? But we said we don't use it on the horizontal plane because your gravity, we don't use this full thing because your gravity would be 0. It won't affect it on the horizontal movement. Right? So that's how they came up with this formula. So let me just take it out. Right? Okay. Right. So here this would be 0 plus 27.778 all over 2 times 8. Watch it.
Actually 11.112.
111.112 meters. Right? So now we can work this out. Okay? So your work done against frictional resistance would be equal to frictional force times your displacement, which is 300 times 111.112, which is 333
53.6.
joules, which is the same as saying 33.334 kilojoules. Okay? Right?
Yeah.
Everybody's lost? Everybody's okay. Next one. Calculate the work done against the gravitational component parallel to the plane. Which force are they talking about? This force. Okay, your gravitational force. So, remember, work is equal to force times distance. This force is mg sine of the angle times whatever distance. So we know this value here, it's 833.8 times sine of the angle, which is 2.862, all that multiplied by 111.112. So when you put in your calculator, if you put it exactly like how I put it with the double brackets, right? Or what you do, work on this part and then multiply by that. Don't confuse yourself, right? Are you okay?
Yeah.
I see.
You do that with
No two covered on CST.
you have
I gave them all the marks. They all made.
it was good from other checks. Vilas was good. I saw good in class.
But yeah, I think so.
You showed all of them.
Huh? I never showed them when I was marking. They came and looked. The inquisitive people.
You never showed me. But let's just make it. When I told you to do level 4, it's easier. Came up, nobody listened to me.
What's a thinner?
There's partitioning this.
46261.
46261. Hello?
0.028.
028 joules, which is the same as saying 462,261 kilojoules. Okay, everybody's okay with that? Yes? 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 Is anybody completely lost? Please tell me now, so before we move on to the next part. Right, Stephen?
Yeah.
How do you say it again? You're okay.
Can I take it down?
Can I finish and then you can?
Oh, okay.
Okay. So, the next one, they ask you to calculate the work that's transformed into kinetic energy. So it's work again, right? The work is equal to force times displacement, right? What work are they talking about? You see, when I said kinetic energy, what would you use to calculate the force? M times A. Okay? We know the mass. Do we know acceleration?
No.
We can solve for acceleration, right? Or you could have said 300 minus whatever this force was. But let's solve for acceleration because I think we're going to use it after this. Right? So, okay. We know final velocity, we know initial velocity, we know 10. We can solve for acceleration. So, acceleration will be equal to v minus u all over t, which is equal to 27.778 minus 0 all over 8, which is 3 point something. 3.3, 3.472. Angry. Right? Okay. So your work, so therefore your work would be equal to the force is mass times acceleration and then all times distance, right? Okay. So this here is equal to 850 times 3.472 times 112. 111.112. Now what you get? Guys, you don't understand what I'm doing, huh? Yeah. If you lost, please tell me. Okay. So I just replaced the F with MA. Because that's the force we're looking at, right?
What are you doing that? D.
No, C.
C. Oh. Initially it's calculating the acceleration.
Because we needed the acceleration to work on MA. Nice.
Not work on the work.
What is it? 327?
27937.344.
This is in joules. Okay, so if you are to write it in kilojoules, it will be 327.937 kilojoules. Okay, that's that. Fine. Still okay?
Yeah.
Good. Next one, they ask you to work out the total force, I think. Okay, total force from the diagram. Which letter are they talking about?
The F.
The F, right? Your applied force.
Yeah.
How would we work that out?
It's left hand side minus
The Newton's second law, right?
Yeah.
The sum of the forces that act on the object is equal to mass times acceleration. How many forces are acting on that object? 3. Your first force is the applied force minus the frictional force minus the gravitational force equal to MA. Right? We're working on this. This value here we know is 300 minus. Okay, so this part here is 8338,5 times sine 2.862 equal to 850 times 3.472. Okay, let's do each part. This is 300. This here is
416.
416.
346.
346.
416.346.
This is okay. Equal to, and then this here 850 times 2951.2. So F would be equal to 2951.2 plus 300 plus 416,346. And what is your F equal to? That's the next question.
3.668.
3.668.
668.
366 point.
No.
3667.546.
Yeah, I'm getting the same.
Yes.
Yeah, okay.
3667. One number of it. Point
546.
546 newtons. Cool? Guys, everybody here, are we okay? Is anybody confused about anything? It's okay. E, they ask you to work out the total power. Power is equal to work done all over time, which is force times displacement all over time. Which force are they talking about? Which is what we worked out there. So when you're doing this, you would have said 3667.546 times 111.112 all over another time.
28 seconds.
It's 8 seconds, right? And what you get?
Sure. 14553.
14553.
No.
That's what I'm getting.
50942.
50942. Oh yeah,
509.
50942 214 watts, right? It's the same as saying 50.9 for 2 kilowatts. Okay, good. Do we all understand what I did? Is anybody lost? Is anybody confused as to why we did something? Is everything okay? Because we okay? Yes. Okay, good. That's good. You want time to take it out? No? Something rub it out.
No.
You don't want to answer me. You see, I was just gonna rub it out.
That's good.
When?
No, actually we did it. You know, for
I'm taking this out there.
yeah, H2S and all that, we actually use it in the SRU. That's the one place. No, for thing, H2S and sulfur and alcohol.
No, chemistry.
Solving for X.
Oh, yeah, obviously.
But solving for X is the thing you use for. They apply it in science, then you use it. You see as your chemistry goes. No, not chemistry, but other stuff you'll do later on.
Even Pythagoras, you don't use it.
Hey, but no, hold
For
on.
10 years experience,
I used to
never use Pythagoras.
I used to use solving for X.
Why?
Huh?
Why is
So when you want to do a reflux or yeah? Okay,
No.
so much. You just gonna you know
You're working with knowns there, there's no
Yeah.
unknown.
It's also
So why are you solving for unknowns? when-
No, we also-
for all the values.
when we were there, we still got a thumb suck. Means I'm
Okay, let's do example 3.8. They tell you that calculate the average power exerted by an engine if it can lift a mass of 250 kgs through a vertical distance of 8 meters, and the time given is 1 minute. Let's understand the question. Yeah? You got an engine in a car. You got a crane that's going to lift it up. Okay? So you hook up your crane, and then you put the crane on, and it starts to pick it up. Right? The force that's being applied to this would be the crane actually lifting the engine up. Right?
Yeah.
What is it trying to overcome?
gravity.
Gravity. Right? So the force that's acting away from it is gravity. So, for you to work out power, you need to know the work. For you to work out work, you need to know the force. So in this instance here, the force will be equal to your mass times gravity. Yes? Okay. So it's the same thing as F is equal to ma, but in this instance your acceleration is gravity. So this would be 250, 9.81. That's 2452.5 newtons. Right? Then work is equal to force times displacement. So your force is equal to, which you just worked out, 2452.5 times 8, which is?
196.
Did I start?
Okay,
Which is?
196.
1962 on the dot.
0. Yeah.
Right. This is joules. Power is equal to work done over time. So this would be equal to 19620 all over 60. Because remember this 1 minute would be 60 seconds. For power to be equal to 1 watt, it needs to be joule per second. Okay? So this here will be
27.
uh,
No decimal.
what? That. Right. Okay.
Homework.
Okay, homework is activity 3.2, question 1, question 2. Before we end today, does anybody have any questions? Anything you want clarification on? We okay? Okay, so tomorrow we're gonna do, okay, we've got that activity.
Sorry, which one is it?
The activity 3.2, question 1, question 2. Okay, so tomorrow we'll do kinetic and potential energy, and then we would be done with dynamics. Then we'll move on to statics. Okay, statics is a bit of a long one. It's a